Assalamu alaikum wa rahmatullah. Welcome everyone to I342 Quality Control, and today we will have we will continue our review for chapter 6 and 7. We will have more 3 questions, problems for control charts, and we will see step by step how we solve the control charts problems, how we analyze the data, how we make interpretation for the results, and how we proceed when we face an out of control events. Today's example, we will start with this one that has a number of non-conforming bills in a lot of size 2,500 units, and it asks you to find the appropriate control chart for the given data and calculate the control chart parameters and show your calculations. Always in the questions, read the questions carefully and answer all the requirements. Don't assume that only a final result or the chart is required. Before reading the complete question and understand all the requirements. So here in the requirement for this question, it says that the first part of A, what is the appropriate control chart? So we have to identify what is the type of control chart. First, we said when we have a data, we have to identify whether it's a variable or attribute, and then we decide based on the decision criteria underneath each category. When we have a non-conforming, is this a variable or attribute data? The non-conforming means the defective, and the defective are attribute data. It is like number of units, proportions, all of those considered to be attribute data. And in the attribute data, we have a couple of control charts. We have P chart, NP chart, U chart, and C chart. For the non-conforming, we have the P and the NP. For the non-conformities, we have the C and U. To recap our review for the control charts, we have this chart here, summarize all the type of control charts. So we are here in this side, where is the defective being detected in the process. So we either use the NP chart or the P chart. The P chart is known for constant sample size and variable sample size. So basically, if you have a defective data or attribute data that contains defective units, the P chart is the safe always decision to make because it fits both the variable and constant. The NP only works with the constant sample size, and it gives or detects only the number of the defective, regardless of how many out of the patch or the sample size is found. The P chart, on the other hand, it shows you the relation between the size of the sample and the number of defectives. It's similar to when I say the number of students score A+ in a course and the percentage of students who scored A+ in the class. So these two make a different indication because it could be a few number, but the sample is less or is few. Out of 10 students, and you have 2 only, they scored A+, different when I say 100 students and 2 only scored the A+. The P chart show you the relation between the original number or the sample size and the number of the defectives. Whereas the NP only show you the number. So here in the example, here we have the data. and it shows you that the sample size is 2,500. And since the sample size is constant, we had a discussion in the last meeting about whether to use the P or the NP. Both charts work with this case. The P chart only, as I said, it shows more details, but using the NP also is not wrong in this problem. So what is the appropriate control chart? First, you have to identify the type of data, and then you make your selection for either P or the NP. Both of them will show you the same results in terms of the visual interpretation for the data. Now, when we start calculate the chart parameters, when we say the parameters, always means that the upper control limits, lower control limits, center line, average, standard deviation, all these values that use for the control chart, we have to calculate them. Now, if we are decided to use the P chart, then the formula for the P chart will be the one that is the control limits P bar, we can name it like this, plus or minus square roots of P bar So the upper lower control limits are the average of P plus or minus, plus if it's upper control, and the minus for the lower control, the square root of P bar times 1 minus P bar, all divided by N. You can review to the P chart slide referring to chapter 7 and to see the formula more clearly over there. So we have to calculate the P bar. The square root of the P bar multiplied with 1 minus P bar divided by N. This is considered to be the standard deviation here in this case. And the upper control limits, lower control limits, also the parameters for that. The P bar, in this case, it is the division. First, you have to divide every readings here in the data, the 230 divided by the 2,500, because this is number of non-conforming. And to find the P, which is the proportion of the non-conforming, we have to divide the 230 divided by the 2,500. So we have to create another column. I will show you that in the Minitab in a few. You have to develop another column here, says that the P. So the P will be the division of the every reading here divided by 2,500 to convert the number of non-conforming into the proportion of non-conforming, which you will use to find the P bar. The P bar, it will be the sum of all the P's divided by 20, because this is the number of readings. So the P bar will equal to 0.1228 to confirm then your answer. And the upper control limits will equal to 0.1425, and the lower control limits will equal to 0.1031. how you calculate the upper control, lower control based on the formula here. You will need the P bar. The P bar, you have to find the P first, which is the division between the and 2,500. And every reading you divide it over 2,500. After you add them all up, you divide them on the number of readings, which is 20. So it will be the P bar. You divide it over 20 times the 2,500. So you have to go to the formula on the chapter 7, which will include the division of 2,520 to get the P bar. We will show all that now in the mini tab. All what you have to just implement the formulas on the chapter 7, and we will do step by step now to calculate each one of those parameters on the mini tab. So let's share the screen now and see how those parameters can be calculated. Okay, there was a technical issue. Now we will share the screen. Can you hear me? Just to check the voice, can you hear me, please? Can you say yes? Okay, thank you. So let's share the screen. Here is the data. The number of non-conforming for the samples, number of samples is 20. And these are the data given in the question. Now this is considered to be number of non-conforming, not the P. The P is the proportion of non-conforming, is not the number. The proportion is the division between the number and the sample size. It's like the percentage. When we talk about the percentage of students, they scored A, and number of students scored A in a class. When you have to calculate the percentage, you have to find the sample size and you divide the number of students scored A divided over the total number. But when you ask for how many students they scored A, you will just show the number of students. So basically, this is the number here of the students in column C2. In C5, you have the P. The P can be, I will show you how you find the P here. I will write this as a P example. How you find this column, which is the division of every reading divided by the 2,500, the given sample size in the question. You go to the calculator here, and you press on the calculator. You choose which column you would like to store your results. So I will choose P example, and I will choose the same. The number of non-conforming, which is column C2, divided by 2,500, because every reading has to be divided over 2,500 to get the proportion of non-conforming. When you press OK, you will see the data filled here in this column automatically. It will be identical to C5. This is just an example. So this is the P values for every reading. To find the P bar, we have to find the sum of all these values, and we divide it over 2,500. So if we say sum of P, we can go to calculator. There are two ways. Either you go to calculator here in the first one, and you select, as we did previously, to find the P value, or you can go to column statistics. This is as you prefer. Both of them are correct. Now you choose the input column, we will select either P or P example. Both of them are the same values. Now you can select the statistic you want to find. So we can find the mean. You can find also standard deviation. You can find the sum. So here you can store the result. It is an optional, but also it will print it here in the screen. So if you choose the sum, it will show you the sum of the P is 2.5. 2.4564. This is one way. Also, you can have it in a different way. We can go to calculator and we can go to the store the value or the results in sum of P. And here we will change the function into sum, and we will change these values into P example. So it will give us the sum of the P example, and you will store the value on sum of P. Again, the result now, it is appeared on the cell, and it is matched to the previous way how we calculated the sum. In order to calculate the average of P, which is P bar, you can say, we can call it P bar if you want, P bar. Again, in the same way, you either go with the column statistic and put the mean, and then put variable either P or the example P. Both of them are the same. Now the mean is 0.1228, is mean calculated previously. Or you can go with the column statistic, which is, I think, yeah, we did this one. We have to go to the calculator. Now we go to the calculator. We will go to store the value in P bar, and we can select the mean. And instead of sum, we will go to the P value, because we want to find P value, and it will be the result stored here in C8 column, 0.1228, and it is matching the other way how we calculated the mean. Also, you can do the same for the standard deviation. The upper control, also you can formulate it here with the same way of the formula, and you can type the formula in the expression space. I prefer to use the calculator for that, because here you have to know how to write the functions and put the brackets. It's like when you do programming in MATLAB or C++. But it works. I mean, if you want to do that, you can calculate the upper control limits, lower control limits here. Or you can do it in the calculator, and you can press them here, and you show the function on a separate sheet when you upload your answer. This is how we calculate the parameters, except for the upper control, lower control. You have to refer to the formula as we did in the slide, and confirm your answer with the written values. As we said, the values in the written or in the calculated, hand calculated upper control, lower control, it will be slightly different than the one generated by the chart. Now, when we would like to calculate or develop the control chart for the P chart, we go to Stat, Control Chart, Attribute, Charts, and then we select the P chart. Here we can select the data, number of non-conforming, because the Minitab do this part here, which is the column of the P, does it automatically. But as I said, in the manual or in the hand calculation, you need to find the P value yourself, because it will be slightly different, depend on the rounding, depend on also the other values, how it's been calculated and how many fractions used. So if you just choose the number of non-conforming, which is C2 column, directly the Minitab will calculate this column C5 by just pressing the number of sample size 2500. When you press this, automatically it will divide the number of non-conforming over the 2500 for every readings, and then it will generate the chart. As you can see now, the P bar, it is almost matching the one we have and manually. Here it's 0.1228, and here it's 0.1228, and here there is a 2, depend, as I said, on the rounding that is used in the Minitab. For the upper control limits, it is 0.1425, and the lower it is 0.13. This is how you do the P chart. As you can see, the chart here contain many out of control, and this is something not normal to have that amount of special causes, especially when we have only 20 sample. So the recommendation will be that process cannot be performed at this level or this parameters of upper control and lower control, and need to be revised before you continue with these control limits. Because when you have 1 or 2 or even 3 out of control, you can try to eliminate them, and then you draw the control charts and you see how is the new control limits with the given data. But when you have this amount of number of out of control, that means the process is not capable to meet the given or the upper control and lower control calculated here. So it needs to be the process revised before you proceed with these specific control limits. For the one who's asking maybe about the NP chart, what about if I use the NP chart? The NP chart, it will be easier to do because you don't have to calculate the P and the P bar. You have to calculate the NP only. If you refer to the formula, you will need the NP, and to calculate it, we can go here to the attribute chart and select the NP. And again, you select the number of non-conforming, you put the sample size, and you press OK. Then the chart will appear to you. And as you can tell here, the upper control limits, lower control limits, since it is working with numbers, not proportion. So this is the upper control limit, or this is the upper number or the maximum number of non-conforming items in the sample, and this is the lower non-conforming number in the sample, and this is the average of the number of non-conforming. There is no much difference between the P chart and the NP chart. I'm putting both charts here. This is the NP and this is the P. As you can see, the out of control appeared identically in both of them. As we said, here to identify further information, because it shows a proportion, and here it shows the number of non-conforming only. Refer always to the simple example when we say the number of students failed the class and the proportion of students or percentage of students who failed a class. When we say the number, it could be sounds high or low, but when you compare it to the number of sample size or the class students or the number of students, it will make more sense, because the 3 students, it could be high if we have only 5 students. But when we say the percentage, it will show you that how is the relation between the sample size or the number of students and the number who failed. So that's why the P chart is more informative compared to the NP, and it works for both constant and variable sample size. These are the values for the NP, and I think you can read it from here. I will enlarge the screen. So in order to calculate and confirm your answer, if you would like to use the NP, refer to those values. So you can calculate it in hand and match your values with the one given here in the figure. So you can verify your answer. Practice this at home because the same formula, it is very similar. You will use the NP instead of the P, and then all the values will be calculated based on the formula in chapter 7. So this is for the P chart and the NP chart example. Let's go back to our slides and continue with the examples. Okay, let's go and make sure that we answer all the questions. Always do that and make sure you answer all the questions here before you upload your answer, okay, to avoid any missing grades in the question. Now, when the question asks, what is the appropriate control chart for the given data? Then you have to answer based on the given data. It is attribute, and there is a constant sample size. We can use P or NP. Regardless, then your selection, then you calculate the control chart parameters, which we just explained how we do that. Show your calculation, then means that you have to show the formulas, you have to show all the details of the calculation. You don't show only the final answer. This is not acceptable. Draw the control chart, and this is how, well, where you use the software application to draw the control chart, and you download that picture and upload it or attach it to the file for your answer. Part C, if you wanted to set up a control chart for future use to this production line, how would you use these data to obtain the center line and control limits for the chart? It sounds maybe a complex question, but basically it's very simple, and answering this question is not too, it is just a few words to say, but missing this type of questions and comments, it will cost grades from these questions. The question asking now, you evaluated the chart. Now, are you going to use these setup for the future? How would you use these data? When you evaluate them and you find this amount of out of control, then this data cannot be used for future use without reviewing the process again, because the upper control and lower control limits are not fitting the process performance. We have seen large number of out of control, so we cannot work with the same exist control limits, and we have to review the data before we proceed with the control limits. If you have a few out of control points, 1, 2, 3, then you can eliminate them, reconstruct the control chart, and you evaluate it again. If you see the control chart, it becomes in control and the process becomes in control, then you can suggest to investigate only on those 3 points and see what was the reason for those points. And you can continue with the new upper control and lower control limits that you calculated them after you exclude the out of control point. So this is if you have 1, 2, 3, let's say, out of control points, but when you have something large like that, and we have a 20 sample, most of them out of control, then that's mean the process cannot perform with these control limits and need to be revised before you continue. Okay, so let's move on to the second example. The second example is the number of nonconformities in the pipes. We have pipes, and nonconformities means defects, and the defects could be appear like a scratch or a finishing, or even sometimes the diameter, which can be reworked again. So again, the question you have to read it carefully. The data above represent the number of nonconformities in pipes. Form your analysis of these data. Would you conclude the process is in statistical control? This has to be answered. What control procedure would you recommend for the future production? Also, you have to answer this. Show your calculation and your chart drawings. So you have to show your calculation for the control limits and parameters, as well as the drawing, and answer those questions in the given problem. When we say number of conformities, now first, is this a variable or attribute data? This considered to be attribute data because it is number of nonconformities. And the second question will be, is it defective or defects? And please pay attention to the wording. As I said, and always mention this many times, pay attention to the difference between nonconformities and nonconforming, and defect and defectives, because both of them, we can say, sides for the same coin. The nonconforming is equivalent to defectives. The nonconformities is equal to defects. Okay, and since we have a defects or nonconformities in this case, we are going to use either C chart or U chart. Now, if we go back to our chart here that is summarize all the control charts, always keep this in your hand to review the decision criteria. Since we have a defect, so we will use either the C chart or the U chart. Now, here is different. If we have a constant sample size, then we will use the C chart. If we have a variable sample size, then we use the U chart. In our case, didn't mention about the sample size. So that case, what are we going to use? Did he mention there is a variable sample size? No, he didn't. So that's mean we have a constant sample size. We will use the formula for the C chart, and the formula for the C chart, the upper and let's put it cap stock. Okay. C bar plus or minus 3 square root of C bar. If it is plus, then it is upper control. If it is lower control, then we use the minus of 3. The center line, the CL, we can refer to, it is the C bar itself. How we do that on the Minitab? So let's share the screen and see how that will be done in the Minitab. Before we move to the mini tab, let's write the the parameters for the upper control and the lower control, so you can confirm your answer later. The center line is 8.59. The upper control, it will be 17.384. The lower control will be 0. So confirm your answer later with these values when you calculated manually. So now let's go and share the screen on the mini tab. Okay, this is the data given. The number of non-conformities from on column C2 and the serial number in C1. So we have number of non-conformities appeared here for 22 sample. Okay, in order to calculate the C bar as we did previously, you go to calculate, choose either the calculator to store the values here on the C bar. So you have to replace this with the C bar and use the mean to calculate the C bar. Or you can go as we did previously also, statistic, and you can select the column here where is the number of non-conformities, and you find the result, which is 8.59. It is equal to the one we calculated using the calculator. Okay. To find now the control chart, basically you go to Stat, Control Chart, Attribute, and then you select the C chart. Then you select the number of non-conforming, and then you hit the OK, and this is the chart appears. Okay. This is how the control chart look like. We have points out of control. So if we refer to the question says, what are we going to do in the future with this process? How we are going to handle those data? First, you have to investigate on those points. We have sample 10, sample. When you press on the point here in the red one, it will show you this textbook, the rectangular one. It shows you the number of the samples. So we have sample 11 and sample 22. So you have to mention those 3 samples were out of control, investigation needed for the reason or the causes for these special causes. Okay. Usually it will be something like raw material is new, they change the material, they change the machine, a new labor is working, he's not trained. So these common reasons for the special causes. Okay, after we write that, what we do, we eliminate those 3 samples. So we have to find sample 22, sample 11, sample 10, and we eliminate them from the data. We eliminate them from the data and recalculate the control limits again. We eliminate those samples and calculate the control limits again manually. It seems there is a question. Let's go back to the screen here. What about, there is a question here, what about the point here? He's asking about this point. This point didn't exceed the lower control, otherwise you will see it in red. Beside the lower control here, since it is 0, when you calculate the values, you will not have something that is in minus, and you can tell from the values here, This is basically the sample. It must be sample 9. Yes, sample 9, it is 0. And basically, this is the lower control. That means it's not exceeding the lower control. It is just on the lower control limit, and that is fine. If you are using the mini tab, automatically it will show you the points that out of control appeared in red colors. But this is also is not exceeding the lower control. It is just hit to the lower control. Okay. Now, what we are going to do, we are going to exclude those points. So sample 10, sample 11, and sample 22. You have to write those number of samples in your answers that mean have to be excluded, and recalculate the control limits again and draw the control chart again and see how the process will work. So this is what you are going to recommend. You have to exclude them, investigate about the causes, and recalculate it again. How we do that? I did that in the column C4 here. I excluded the samples that were out of control, and as you can tell here, because there were 3 samples only, we have now less number of samples. It is now 19 instead of 22 because 3 of them, they were excluded because they were out of control. Now we calculate the C bar again, as we did here previously. You do it here for the new data. As you can see, the C bar, which is the center line, it becomes to 6.6, and it was 8.5. So that means the upper control limits, the lower control limits will be different than the one previously drawn. So we redraw the control chart after we exclude those data based on the new data in column C4 and the C bar, the new C bar, which is calculated. The C bar automatically will be done by the mini tab, but you have to calculate it to show the manual calculation. Now, here is the chart. Let's open them next to each other, okay? So let's enlarge this one here, which is the old one, and this one here is the one after the modification. After the mod, which is referring the modifications, okay? Now, this is the comparison. You can see now the process, the upper control becomes 14.3. The lower control is 0, and it is commonly be like that in the C chart or U chart. The average, which is now is 6.6, and it was 8.5. We have only 1 point out of control or out of the upper control limit instead of those 3. So what is going to be your recommendation? Now this is the old, and this is the new after the modification in the data. So you can suggest now, since the process becomes better in terms of the performance compared to the previous one, the new control limits will fit or suit the data more than the previous control limits. They have to investigate about the causes, and also they have to investigate about this sample, which is sample 13, and see what is the reason. If you would like to perform more investigation, you can eliminate this point. You can eliminate sample 13, and you recalculate the control limits again and see if the process becomes in control, no points out of control, then you can use the latest control limits. If there is still 1 point, you can refer to this one. This is acceptable to have 1 point out of control like that. Usually it is something that shows a special cause here happens, but the process in general, they have to monitor it. Doesn't mean the process now it is perfect, but based on the sample we have, they have to monitor it based on these control limits. They cannot go with these control limits anymore because these sounds more better or more fit to the data, and they have to collect future samples and draw them on the new or on the exist control limits, which is calculated, and compare them with the previous data. If there is no out of control points appear, then the process is in control. If yes, then they have to investigate on those out of control points and remove them and do the same. So basically, you start look for the out of control. If we had like the one previous example, too many, you have to say the process need to be revised before they continue with these control limits. And you don't do the excluding because it will not make sense to exclude half of the points. When you have something like that, small number of out of control, you recommend investigating for the special causes, you exclude those points, and you redraw the control chart based on the new control limits and monitor the data. If the data become like that, is stable and only one point, you can exclude it again and draw the control limits, and you can try this home, see if the process becomes in control. Or also you can say these new control limits, it fits the process more better, and the company or the production line, they need to monitor the process based on these new control limits and see if there is any out of control points are appeared, as well as they have to investigate for this one. Okay, so this is how we do for the investigation and the recommendation for the companies when we see out of control points in the control chart. Let's go back to first verify that we answer all the questions before we go to the third example. We have to read and make sure that we have answered all the example, all the questions required. The data, it says, would you conclude that the process is statistically in control? So from the first trial we did, no, the process is not in control. What control procedure would you recommend for the future production? You do the same as we said. You said you are going to investigate on those 3 points. What was the causes for these special causes? Then you do the eliminating points, and then you calculate the control limits again, and you see the process. If it becomes more stable, then you can recommend to them to use these new control limits, or using these control parameters, center line, upper and lower control, and also investigate if there is one point, what was the causes. You can try if the process becomes better after you exclude that point, so you can refer to the latest control limits. Otherwise, you can also use the last one, which is the one that has only 1 point, because that is something normal to have. But then you can recommend that to use the new control limits, and that will suit the data or the process more. Okay, this is how you interpret and analyze the control charts after you find them. A third example we have here, which is a data given for number of non-conforming, and we have a sample size. In this case, we have a sample size, but if you pay attention, it is varying. It is not the same, it's not constant. Sometimes it becomes at 200, and then sometimes at 250, or 150, or 100. So even though the changes are not really spread over different numbers, but even though it is around only 4 numbers or 3 numbers, but still the sample size is not constant. and the number of non-conforming, meaning that it is the defectives. So if we went to the decision criteria, it will be exactly the P chart because it's the one that fit for the non-conforming and variable number of sample size. Now we answer again and read the questions carefully. What is the appropriate control chart for the given data and calculate the chart parameters? Show your calculation. Pay attention to this note. Draw the control chart. That means you have to generate the control chart on the mini tab. Evaluate the process, and that means you draw the control chart, do the same what we did previously about the charts. Now when we calculate the P chart, we go to the same formula that we have done previously. In the first example today, we have solved another P chart, and you can refer to the formula on that example or on chapter 7 slides, where it contains the formula for the P chart for different number of sample size. Now the question may ask, okay, how I'm going to calculate the parameters for a variable control, a variable sample size? It is very common questions you may have. Okay, I can do that on the mini tab automatically, but how I'm going to draw it? In a case like this, we have only 4 different sample size. Then you can calculate the upper control limits and lower control limits for only those 4 different sample size. So you will have a pair, ZOJ, of 4 control limits. The control limits, they will be n, when n equal 100, when n equal 100, you calculate the upper control and, sorry, the lower control, it will be here. The lower control will be 0, and the upper control will be 0.0. When n equal 150, then the lower and upper equal when n equal 200, then the lower control and upper control will be 0.533 or 0.0533, and when n equal to then the lower will be 0 again, and 0.5 is the upper. This is to confirm your answers with the answers. You will calculate them. Now calculate the lower and the upper control limits are based on previously in today's example and in chapter 7. Since we have only these 4 different sample size, you can generate or draw or calculate the upper and for every sample size. When it is 100, you calculated the upper control and lower control for the sample size 100. And that will include the data only when the sample size is 100. When you calculate the upper and lower control for the sample size 150, you will calculate it only for the data that has 150, and the same for the 200 and for the 250. Remember, of non-conforming, that means it is NP, not P. So you have to divide this number over the sample size. You have to divide the 6 over the 200, the 8 over 250, and so on. Okay? These are the values given here, so you can confirm your answer later. When you draw the control chart, you don't have to do that. This is only in the manual or the hand calculation. On the software, it will calculate the control limits automatically because it will detect the sample size in the column of the sample size and will calculate those automatically. So let's see how it will be done on the mini tab, and from there we can see whether this control chart shows that the process is in control or not. Okay, sorry, the voice was not working. Now it is okay? Yes, it is good now. Okay, so let's repeat again, okay? So let's repeat it again. Now, column C3 shows the number of non-conforming, and C2 is the sample size. This is based on the given question. C4, let's see if it can undo, but never mind, we can do it P example. This is how to calculate the P. The P is the division of the number of non-conforming divided on the sample size, because this is considered to be NP. This is NP, okay? And this is the P. How we calculate it? We go, I will do it again here in column C5 since the voice was not working. So we go to the calculator, we go here, the first choice, the calculator, and you use where, first you have to choose where you want to store the data, then we have to select here, I'm going to choose C5 instead of C4 to show you again. The same function, You select the number of non-conforming, then you can hit on divide, then you select the sample size, so it will divide every reading, number of non-conforming divided on the sample size, and it will store it on the column here. So this is the P. To calculate the P bar, previously, let's do the column statistic here this time, so we can change the way. So we choose P example, and that will be the P bar value. You can type it here, or you can calculate it using the calculator. P bar, so we will store the data on P bar, and then you select the mean for the P example. Okay, let's delete those. Press the mean, double click, then it will show you already where you press the data or where you select the data in blue. So just go and double click on the column you would like to choose. When you double click, it will put the data in the place of the blue font. Now when you press OK, then the value, and how you calculate or how you construct the control chart. We go to attribute chart, and then we go to the P chart, and we select the number of non-conforming, because the control chart on Minitab, he will do the calculations for the p-value automatically when you put the sample size. Here, we don't have a constant, we have variable sample size. So you will select the column where is the sample size, which is column C2. So you go to C2 and double click. So it will be the sample size pressed, entered here. He will divide the number of non-conforming over the sample size automatically to draw the control chart for a variable sample size. Now, when you press OK, it will show you that the upper control limits, you can see, let's enlarge it. You see how the upper control limits are varying because of the number of the sample size. When it shows you here the upper control limit, it shows you that an average of all those upper control limits, because as we say, the upper control limits are varying, because the 0.05 here is not representing the upper control here, which is 0.06. When you go and click on that red line, it will show you the control limit here on this part. It will show you the control limit here on this part, 0.58, and here it is 0.05. Here it is 0.053. Here it should be 0.053 again. So here, how you can confirm your hand calculations for those upper control limits with the one drawn here on the Minitab using the formula and using the software application. The lower control limits are 0, and those points again are 0, so they are only on the lower control. They are not exceeding the lower control. So we can say now to the production line, the process seems to be in control, and they can keep monitor the data using the same control limits that is calculated. This is the last example was for the control chart. I hope those were helpful to review the material for chapter 6 and 7 before we proceed to a new chapter, which is the process capability, which is very important also chapter that is actually needed to investigate if the process capable to be performed under those specifications set by the customer and the organization. And it is usually even in Six Sigma project is done before you start draw the control chart to make sure if the process is capable or not. So that's all for chapter 6 and 7. Now it is the time for the questions and taking the attendance.